yeah, Rithwick, we can start.
Okay.
Uh, oh, okay, the math class is an inbuilt. So today we're going to do the math and scanner classes. The math class is an inbuilt Java class used for mathematical functions. It contains several useful functions which will make life easier. These are some common functions in the math class. Math.abs is a particularly useful function. It returns the absolute value of a certain number that you put in as an argument. Math.max and math.min are also useful because they return either the greatest value among the two arguments or the smallest value depending on the function you use. And then math.pow is basically exponentiation. You do a to the b. And then math.square root is pretty self-explanatory. Math.floor returns to round it down to the nearest whole number, and then math.ceil does the opposite, it rounds up. And then there's also other methods
Yeah, there are
that
also
interest
like
me.
trigonometric functions like sine, cosine, tangent, etc. So
Yeah, sine inverse and stuff like that. Um, math.random. This is actually a very common method that teachers will use to get you acclimated to the language, and it can be manipulated greatly. Math.random returns a double, which is greater than or equal to 0 and less than 1. So like 0.999 is the last number that you will return. In interval notation, it's this if you know what that is. Uh, okay, this is how you use it. You create a double named something and you say math.random. And then here, or you can do either of these things and more. You can create an integer variable and you can cast, and you can do random times 100. So if you want a number, a random number, but you want it in a certain range, you can decide what range that's going to be. Here we're going to do 1 to 100. And so here what we're going to do is multiply random times 100. So if random was 0.99 and you multiply that by 100, uh, we're going to get 99. So since that's the last possible number that random can return, this statement is gonna be 99 from here to here, uh, as an integer, and then we're gonna add one. So that's gonna be 100, and a similar, and the lower bound will be one. If you do the same process once again, and then here we're just not adding one, so it's going to be 0 to 99, as it would just be this, so it would be 0.99 times 100.
mhm,
So the upper bound here is specified with the times 100 part
mhm,
of this equation, and the lower bound is specified with the plus one at the end. So if you want your lower bound to be like say 5, you'd put plus 5 at the end, and if you want your upper bound to be like I don't know, like 400, then you would put multiply by 400 instead of
mhm.
100.
Yeah,
Yeah.
and like the typecasting to to an integer is basically kind of used as like a math.floor method right here. It's basically just used to round down. Like for example, if rand num was like 0.997, and then you multiplied that by 100, it'd be 99.7. But you typecast it to an integer, so it automatically rounds down to 99, and then plus 1, it equal 100. So yeah.
Okay. This is basically the same thing that we did yesterday, where we were formatting numbers. You can just use the slides from the other day to see which of the percent and the letter after that you should use. You can use it to format numbers in a certain way. So here it's gonna do percent point to F, which basically means we're gonna round this to two decimal points,
Hmm.
because of the two.
Yeah, and there are also
Uh,
like yeah, there are different ways of doing it too. There's like big decimal, which is another class, and decimal format, which basically just do the same thing. Yeah.
the scanner class is also very useful. I will demonstrate what how to do this because it may not be that intuitive.
Hmm.
Alright, here we're basically so this is the standard way of doing it. You say scanner input equals null. But you first have to import it though from java.util, and then you actually let's do this later. Let's do this one. We're gonna do scanner input equals new scanner system.in, and then we're gonna get the next line. So basically in the command console, you're gonna type something in, and that will be input. So no, that will be the next line, and it's gonna be printed here, and then we're gonna close the input.
Yeah.
Uh, and then
Yeah.
this is for text files.
Mhm.
Uh, Here we have a string name, file name. We're gonna scan that file in. We're also gonna try catch it, which we'll learn about later, just in case there's an error of some sort. Uh, and then we're gonna do a while loop. And basically what this does is that as long as there are new lines in the text file, we're gonna keep trying to get through all of them, and we're gonna print each of those lines. And then at
Yeah.
the end, we're gonna do input.close
Mhm.
to prevent memory loss. So yeah, uh,
Yeah, and we can demonstrate on REPL right now.
yeah, or VS Code.
Mhm.
So I've already imported java.util. Uh, so this, okay, I've already imported that. And then we're gonna do input equals new scan system dot in. Um, and then we can do whatever we want. We can just say, let's just do the same thing we did there. And then we can close the input. It's not gonna throw an error if you don't, but it's just good practice. And then we can okay, now we can just type something in, and then it prints back hi to us. So that's
Mhm.
that. I don't want to do the
Yeah.
file one because I don't have a file right now. We can do that later if I
Mhm.
do that. Okay, okay,
Yeah,
cool.
so you can use the scanner to like ask your user for their name, their information, etc. It's pretty useful.
Mhm.
Okay.
Yeah, and we can demonstrate the math class right now.
Uh, X. We can do math dot. We can do actually let's make this 3.3, and then we can map dot seal X.
And
So
yeah, and
uh
predict what will happen. Just like raise your hand
yeah,
and
does
Yeah.
anyone want?
I'll call on someone if no one wants to volunteer. Um,
Oh,
yeah, three.
can you
I
Yeah, hello.
Mhm.
yeah,
yes.
Yeah, I don't know. It like maybe it'll like just print 3.3 or maybe
Okay.
like I don't know. Maybe
Okay.
6.6
Why do you think 6.6?
cuz like double of 3.3 is 6.6.
Okay, double
Mm.
is the data type of
Sorry.
3.3.
Yeah,
Yeah, yeah.
my bad. Sorry. I just realized that.
Yeah, it's the
Okay.
Yeah, it's just like a decimal. So, yeah, what do you think the math.ceil function does or method does?
Okay,
Uh,
I see Jithan and Janae also wanna. We'll let Shri finish and then they can go. Bro, Shri.
yeah, sorry. Yeah.
Yeah.
Now I don't really know. I don't have an idea like what the
Okay,
math.co would
let's
do.
have someone else come in to explain.
Yeah.
Okay, let's have Janae
Yeah.
and Jithan. Oh,
Yo, I get to talk. Okay.
Oh.
I think it's gonna print out 4 because it rounds
Okay.
it up to the nearest
Hmm.
integer, and 4
true,
is the next one. I listened this time, Ashwin, don't worry.
true,
Yeah, yeah,
true.
yeah. Yeah, so that's yeah, I
That
guess
that
Jeanette,
yeah, that's pretty much it.
yeah. Jeanette, were you gonna say the same thing?
I think Janae left.
Oh,
Okay.
wait. Oh,
No, like he's in the call, but he left the
wait.
stage.
Okay.
Okay.
Yeah, I was just gonna say 4 because like the three will get rounded up
True, true,
with the
Yeah,
ceiling
okay.
function.
Okay.
true.
Very cool. Well,
God, that's crazy.
So
yeah.
what would floor do actually?
4 would go down, it would go to 3.
Yeah.
Oh no, it's not this. Yeah, it would just be that. Okay. Uh, we can do math.amps.
And does someone want to chime in on what they think will happen?
It's gonna print out 3.
Yeah.
Yeah.
Okay.
Okay. Let's- what other functions? Oh, we can do
That would be 3 to the power of 9, right?
Yeah.
yeah.
Yeah, base, yeah.
Okay. Okay. I think we understand what that is.
Hmm.
Okay. Let's go back to the slide.
We should demonstrate some of the like random number generation real quick. Yo, why is Janae still here?
Yeah,
Wait,
Jeanette.
Janae,
Oliver,
go
give me a
back to the
second. Wait,
audience.
remember that one
It's
project I
floor.
was showing you that has some good examples of random number generators?
Yeah,
Okay,
Wait,
okay, well,
what did he say?
real quick.
That's
Let's do a random number from like 5 to 500.
Okay.
Yeah,
Um.
yeah. So you cast it to an int, take a random number, and remember the math dot
Wait, what
random
was it?
it was
5 to
500,
500.
500 plus 1. Or, I guess
500.
5 in this case.
Yeah, plus 5.
Hmm.
Yeah.
Or, well,
So
you'd have to the cast the rand first.
I don't think it matters.
I think it would, because if like you multiplied like 0.996 by 500, that's like 498. So if you added like 5 to it, then it, I don't, okay, what,
Oh wait, no. This is correct. Okay.
yeah,
Oh, okay. Actually, the bracket should be here.
okay. Then yeah, just print out
Okay.
X.
Oh, I didn't
Oh yeah,
print that.
you gotta print it.
Yeah, so math dot random gives us a random floating point,
Do you know what this?
decimal from 0 to 1, and then you can multiply it and cast it to get your random number. Okay, so we got 5 twice in a row. Okay.
Wait. I think this one.
I know, because the 0.99 is rounding down to like 0. like point, yeah. Yeah, do that, yeah, that's about it.
Okay, I'll
Yeah,
just
okay,
write
that's
down
better,
this
that's
one.
better, that's better.
Okay, let's try one more
Okay.
time
Yeah.
just to see.
Okay, actually, let's do a different set of digits now.
Okay.
Or we could do it one more time. Maybe 326. Okay. What let's do 0 to 32. So here we wouldn't need the addition. You can just do 32. So yeah.
Okay.
Mm.
Okay, 0 to 32, and you got 23. Try one more time. Just see what you get. Nice.
Nice. Very cool.
Yeah, so always remember that math.random gives you a random decimal number
Mm-hmm.
from 0 to 1,
Yeah.
Okay.
non-inclusive.
Yeah. Any questions so far?
Just like request to speak if you have a
Yeah.
question.
Or you can type it in the chat. Okay. Let's go to conditional statements and loops. Preface. Sometimes we want to make our code smarter. To do this, conditional statements can be used to create alternative paths for your code to execute. Loops can be used to repeat a certain section of code a dynamic number of times. Okay, we can just go to this and you'll understand what that means.
Yeah.
If a certain condition is true, execute something. Okay, here we have an integer named rest, and if we're basically making multiple pathways uh, of what this, oh, we have a method named example, and we're getting an integer from the calling agency, which is num. So here we declared an integer named rest. If num is less than 6, we don't know what num is. Let's just say num is 4 for now. If num is less than 6, which is true, it's 4. So we're gonna say rest equals num plus 10, which is 4 plus 10, which is 14. So we're gonna return 14. That's done. Like we're not gonna go through the rest of this because we already know that num is less than 6. That's the only thing that matters. But let's say num is 32. If so, here we're gonna go here. Else if num is greater than 6, let's just go back. 32 is not less than 6, so let's go here. So 32 is greater than 6. So here we're gonna say res equals num plus 20. So it's 32 plus 20, which is 52. So let's return 52, and that's done. We're not gonna go here because this is the only thing that matters. We return res. Once you return something out of this method, you don't really go after you don't go after
Mm.
it because you just leave the method
Yeah,
call.
yeah, it just like
The
breaks
method
out of
call.
the entire method essentially.
Yeah. And then now let's say num is 6. Uh, if num is 6, it's not num. We can go here. We're gonna say 6 is less than 6. That's not true. If you go here, 6 is greater than 6. That is not true as well. So we're just gonna go to the final else body. And it's gonna say rest equals num plus 30. So we're just gonna do 6 plus 30, and we're gonna return 36.
Hmm.
So
Yeah, and it's really important to have the else clause, like the else if statement, because if you wrote an if statement and then after it you wrote another if statement without the else in front of
Hmm.
it,
Yeah,
both both of those
would run.
could be true,
Yeah.
and then that would cause an error. Yeah.
Yeah, I get
So
it's
you
more so
always have to put the else if.
yeah, it's more so that like both of the if statements would like evaluate. Because like
Yeah.
if it's just like one if, like let's say like multiple else ifs and then one else, then only only the one if would evaluate at least, basically. So okay, if the first if is true, then none of the other conditions are, or none of the other statements and conditions are like evaluated. So like it goes sequentially from like if down through all the else ifs, and then else if none of the conditions are true.
Yeah.
Sing single line
Yeah,
if statements.
yeah. We can after this slide we can go to like VS Code and then uh,
Okay.
Yeah.
demonstrate.
Single line if else statements. If your if statement block is one line long, then you don't need parentheses. Okay, this is a special case. You can have parentheses if you want, but you don't really need them.
This
Oh
just
wait,
makes
if
it a
you're
lot more concise, you know?
Yeah,
Yeah. A
okay,
lot
yeah,
more readable. Like
yeah,
this
but
kind
yeah,
of
it
reads
just needs
like
to.
English. Like this
yeah,
this basically reads like English. Like if number is less than 10, return less than 10. Like yeah.
yeah, but of course, like you still need a semicolon, but yeah.
Yeah.
So yeah, we can go to VS Code and demonstrate the
Oh,
if else statements.
Yeah. Interesting way to think about if statements. Think about like school grades. Like if
Hmm.
your grade is
oh, let's just
from 100 to 90, it's an A. Yeah, something like that. Yeah. And then
okay.
AD,
Let's just say 96. Okay, for simplicity.
we'll just do A, B, and C, and then anything below that is an F.
Also, you can declare strings as this as well. You can construct them. You can do this. You don't. It's probably easier to just use double quotes, but this is I don't know.
It
You
just
can
like
do it if you want.
instantiates a new
Yeah,
string object. So
yeah. If you do if you do it like this is implied instantiation.
mhm.
Um, and
Yeah,
then if so, then letter would be A, I guess.
yeah,
And then else if grade is
I guess it's greater than or equal to A.
yeah, if grade is
Yeah.
I don't know what a B is.
B is like 80. Well, that's B minus, but we'll just go with regular letters. 80, 83.
Let's just say 90 is an A, and then
Yeah,
80 is a B.
yeah. But also, it has to be and less than.
Yeah.
Yeah. So that's the
Hmm.
Boolean logic we talked about earlier,
Hmm.
like yesterday.
Yeah, that's the logical operators, the logical and. So
Yeah,
Let's just say let's just say an exact 90 is an A, an exact 80 is a B, and then um we can say letters, and then let's just say everything else is a C for this for the
mhm.
purposes of this assignment.
Yeah. Yeah, so again,
Uh,
like if so the program has to go through all of the if and else if statements before it evaluates the else statement. So
yeah,
yeah, and
okay,
obviously like the else statement, you don't put a condition because
yeah. So this will
yeah.
give back
Hmm.
A. But let's see what happens if you forget to put the else in front of the second if, line 9.
Yeah.
So I take that out because this is a really common mistake and it'll completely screw up the logic in your program.
Hmm.
So let's just
Yeah.
see what happens.
Yeah.
oh,
Yeah, so you get C, which is strange, right? Because like
Yeah.
a 96.
Yeah, but yeah.
So
Yeah.
yeah. So first it evaluates and sees if it's greater than 90, which it is, so it switches letter to A, but then it goes again and sees if it's greater than or equal to 80, which it is. but the grade also has to be less than 90, which
Mhm.
it's not. So the
Yeah.
Boolean expression in this second if statement turns out to be false. So then it
Yeah.
just defaults to the else statement
Mhm.
and sets the letter to C, and then that gives you like the completely wrong
Yeah,
like
yeah,
letter.
yeah, definitely. You can think of it as like two sets of statements. So like each statement has to have like basically an if statement, could have an else if statement, and could have an else statement. So the first statement is like that if grade is greater than or equal to 90, where it like the letter equals A. And then the second statement, well, Rithwick just deleted it, but it was like the if is if grade is greater than or equal to 80 and grade is less than 90. So that's the beginning of the second statement. And the else, where like letter equals C, is a part of the second statement as well.
Yeah.
Okay.
Mhm.
Let's go. Okay, single line. Okay, switch statements. Switch statements are kind of fancy. You don't really have to use them, but they can be useful in certain cases. Uh, I don't think there's any realistic examples here, but basically how the syntax works is that switch value.
Mhm.
For you can just use this, and so let's just say there's a value here. Don't worry about where it comes from. It's just some random value, and then we're just going to go through all the possible cases of these of the value. So if in the case that the value equals 1, we're gonna execute the function do something with the argument of 1, and then so on. So if the value equals 2, we're gonna do something um, with the argument of 2, and so on. And that you can actually have a default switch state, the default case where you're gonna do something in case
Yeah.
it doesn't mean any of these other things, which
Mhm.
we don't have here.
Yeah, basically like the default is the else statement of this switch statement essentially.
Yeah,
So if none of the
and
cases are, if none of the other cases are true, then the default is evaluated.
Yeah,
yeah, and then
I
there's
would
also
highly recommend you use switch statements if you have
Mhm.
like a large amount of if statements or
Yeah,
something.
definitely.
Like for example, if you have like a list of like colors or like days or like people, and you're trying to check if it equals to this color or that, and just use a switch statement for that instead of a regular if statement. So
Mhm.
yeah, it's a lot faster. Yeah.
Oh, we have a default keyword. Oh,
Yep.
okay, this is here. So what happens if no case is true? That's what the default keyword is for. The code under default is run with which, if no case is true, there's no break statement needed since it's the last statement. Um, oh yeah, we didn't talk about break statements actually. Uh, okay,
Yeah, so the
okay,
breaks, yeah, I can explain. So like the break statement is used, so like if a case is like, if one of the cases is true, then it automatically like breaks out of the entire switch statement, so none of the other cases are evaluated.
Yeah.
Yeah, so
yeah,
like you can think about like the if statements where like if like the first if statement is true, then like the else if statement and the else statement aren't evaluated. You can, yeah, so like you can think of it similarly this way, where the break makes sure that none of the other cases or the default are evaluated.
yeah. Um, while do while. Uh, so this is basically a while loop. While something is true, you execute this certain function repeatedly. Used if you don't know how many times you should iterate. You would if you know how many times you should iterate over something, you would use a for loop. Both do the same thing, but do while executes the statement first and then evaluates. So here we have a normal while loop. So while I is less than 5, you can you're gonna print out 0, 1, 2, 3, and 4 because you're basically taking I and you're printing it repeatedly until you reach 4, because you're incrementing I every time you pass through the while loop here. And then the do while loop does the same thing, uh, except it has the while statement here, and it also does the same thing. It also prints out 0, 1, 2, 3, and 4.
Yeah, and we can honestly go to REPL and showcase the while, do while, and switch statements.
Yeah.
Yeah.
So while loops, the distinction is that you specifically use them if you don't know how many times you need to loop through a piece of code to achieve your end result.
Mm.
I mean, you
Yeah.
can use them even if you do know, just if you prefer it that way.
I mean, if you do know, the proper practice is to use for loops, which we'll talk
Yeah.
about. Yeah.
Yeah.
Anyways, uh, we're just gonna do while I is less than 5. We're gonna do the same thing. Make it 10 for some variety. I guess this.
Hmm. Yeah. And notice how
Mm,
I was using the post increment to basically increase I by 1 every iteration. Yeah.
Yeah. And there you go. We
oh,
get 0
oh,
through
we can see.
9. Notice that you get 9 instead of 10, which sometimes confuses people. If you want to get 10, or in this case 7, you should put a less than or equal to in the condition. Yeah. Yeah. And if you want to
Okay.
start from 1 instead of 0, you should just set I to 1.
Then you
Yeah.
can try doing this.
So
We're
these are
implementing.
useful for printing out numbers in order, or just like executing a block of code while a condition is true, which can be useful and a lot of applications in the real world.
Mm.
Okay. Um, let's go. Okay, for loops. Loop through code for a known amount of times. Code below will start iterating at 1 and 2 and not including 20. Okay. So basically the syntax is, here we're gonna declare an integer named I. I is the standard variable used in iteration. Um, so we're gonna start at 1 and we're gonna set I equals 1. And then the second part is basically indicating that I, as we're gonna continue looping until I is less than 20. And we're gonna get there by continuously incrementing I until we finish the loop. So, and then here we're just simply printing. All right, so this code will print 1, 2, 3, 4, 5, 6, and so on until you get to 19. Okay, nested for loops. When you put a for loop inside of another for loop, yeah, these are used for 2D arrays. And then it does use more computing power. Example is selection sort. Uh, I don't want to do this right now because sorting algorithms are pretty complicated. They're not complicated, but they're tedious. But we can do these types of nested for loops. One useful thing about nested for useful thing. Oh yeah, we already talked about that. Okay, here we're gonna basically have this for loop is inside this for loop. So this for loop is gonna start at I equals 0, and it's gonna loop through all the uh it's gonna loop through all the it's gonna loop through all the rows first, and then it's gonna go through the columns. So here we're printing nums I j. We, You can go here. Actually. So here we have an integer array of so here we're iterating through the matrix in row major order. So we have basically the same thing that we had here, and we're printing it out. I can't really show what it's gonna print out because we should
You
probably
can
do this.
show it in VS Code real quick.
Yeah.
Just copy and paste the code.
Oh, I don't know if you can copy and paste it, but
No.
it's a picture, so. But
Okay.
It's not a picture. It's like written text.
okay. Okay. Oh yeah,
So
mine was a picture, I think. Yeah.
okay, so here we have. So we're just printing out the values in the exact order that they appear, uh, because it's printing out matrix ij. So it's gonna start here, and then it's gonna go at j equals 0. It's gonna go here. When
Mhm.
it's I equals 1, it's and oh no, we don't go there yet. If it's I equals 0, and then we're gonna do j equals 1. So we're gonna print this. And then
Yeah.
at j equals 3, we're gonna print this. And then we're gonna go back here because we've already finished this row. And then we're gonna do uh, I equals 1, which is this. And then we're gonna do 4, 5, 6, and so on. So that's row major order. And then there's also column major.
Mhm.
So the important thing
Jeez.
with row major and row column is you'll see right here. Okay, so right here you see something interesting. So this is in fact column major order, which means you loop through the columns first and then the rows inside. So with that, if you go back to the diagram in the slides, or you can stay here, you get the columns, the individual columns first. So like one column of that matrix is 147. So you get that listed out first, and then 25A and the 369, because those are all individual columns. Whereas if you go row major, it'll be the other way. Like you'll get 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can show us a row major. And another important thing for row major and column major is the rows is defined as the matrix length, whereas columns are defined as matrix as the length of the first element of the 2D matrix. So that's an important distinction. Don't get that messed up, because I know a lot of people, including myself, that get that mixed up, and that'll cause a lot of
Mhm.
problems. Yeah.
Well, the slash and ampersand. Okay, this is row major order. So basically, we're
Yep.
just going as you could see it here, 1, 2, 3, 4, 5, 6, and then this is column major order because we're traversing uh with the columns coming first. So we're looking at the first index of each row first, and then we're progressing to the second index and so on.
Mhm. Okay. Well, do we have any questions?
There's a homework.
Yeah. Oh yeah. I
No,
don't
we're
think we
not
went.
done.
I don't think we went through switch statements. Uh,
No, we did.
no. Like
Okay,
in
we have
VS
for
Code.
each actually.
Oh yeah. Yeah.
You could also go through
For
for each.
cycling through arrays and other types of collections, we can use for each. Variable must be the same type as the base type of the array. We can just demonstrate this and switch statements.
So
Mhm.
for each is interesting because um the int I there, it creates like a copy of the element in the
Yeah.
array. So
Yeah.
it creates a copy of the element, and I is just a
Mhm.
copy of what's in that element of the array. It's pretty cool.
Yeah, so like it's used exclusively for like looping through arrays pretty much and like other collection objects. But yeah, as Ashwin mentioned, it like substitutes how like we normally access array elements by like having the brackets and then having like the index we
Yeah,
want it inside of the
see,
brackets. It
Rithway did something pretty useful here.
yeah.
So this code right here
Uh,
causes an error because
yeah.
he's doing nums
Mhm.
I, which
Oh
is
wait.
Yeah. Yeah,
yeah,
yeah.
which is the usual way you would get the elements. But remember, int I here, it's a literal copy of the
Actually,
element inside the array.
Mhm. Yep.
just don't use I here because I often think of I as an iterative
Yeah,
variable as opposed
Yeah.
to as a actual meaningful number.
Mhm.
yeah,
Yeah. And yeah, like
yes.
So just
yeah.
So that mistake right there is really common, and we have Rithway just doing it. I've done it. It's like it's very common. Just remember that
Mhm.
the int num there, the user defined, is just a copy of each of the elements inside the array. So you don't have to say nums brackets num to access that element. You just have to type in num and you'll get it.
Mhm.
yeah, this is just an alternative way of doing for loops. Let's do switch statements now.
Yeah. Yeah, so if you recall, switch statements are basically meant to replace large, like if-else statements. So,
Let's just do let's do or let's just do 5 actually. So it's easier. Let's just say case 1. We're gonna let's go. We're gonna system misspelled it. And then we can do case 2 system dot. And then we can do 2. And then if it's not either of these, let's just do default. Um, I keep misspelling system. And then we can just do some. And then oh, okay, now we can. So now we know that it's some random number because it's not either 1 or 2. And then if you put 1, you can just see that it's just gonna say 1. So it's not that complicated. Okay, we can go back to the
Mhm. Any questions? Okay, yo.
We can get
Looks
into
like
the
the
homework.
yeah, the homework, same deal as always.
For I can post it in announcements.
Mhm.
Yeah.
Yeah. Okay. Well, that's it. I mean, that's it. Do we feel good? It's not hard. It's not hard at all. It's pretty simple stuff, just know the fundamentals.
Yeah.
Okay.
So I'll post the homework in announcements. You guys can do it at your own pace. And yeah, that's pretty much it.
Hmm. See you guys.
YouTube